This video is on strong and weak electrolytes. So remember that an electrolyte is a compound that will dissociate into ions and then it will conduct electricity. So a strong electrolyte is a substance that dissociates 100% into ions in aqueous solutions. So, meaning every single ion will be separated. Like none will stay together with like a cation and an anion. And it must be in an aqueous solution. So it must be dissolved in water or it will not separate. So examples of this and things you should know that are strong electrolytes. One is strong acids, and we'll list them in a second. Another is strong bases. And then the third is ionic compounds. So remember, ionic compounds are when you have a metal and a nonmetal, or typically like a cation and an anion. So these would be things like sodium chloride, potassium sulfate, ammonium chloride, anything like this, where you have a positive and a negative. All right, so the strong acids, there are 7 of them. And you will need to know these 7. Because anything that's not on this list that is an acid will be weak. So if you know the 7 strong acids, any other acid you know would be weak. So there is a Quizlet in Schoology for you to practice these with. Make sure you know them. So the strong acids are HCl, HBr, and HI. So these 3 are binary. Oops, hold on. Right, meaning they're just hydrogen in one element. And then there are some that are ternary, and they are HNO3, so nitric acid, HClO3, HClO4, and H2SO4. And these are ternary. And if you remember, that's how we name acids. So the first 3 binary, they all start with hydro. So hydrochloric, hydrobromic, hydroiodic. Ternary acids, you just take the polyatomic ion ending and change it. So HNO3. NO3 is nitrate, so that's nitric acid. ClO3 is chlorate, so that's chloric acid. ClO4 is perchlorate, so that's perchloric acid. And then sulfate for the last one would be sulfuric acid. So the strong bases, there are 8 of these. And these are going to be your group 1 and group 2 hydroxides. So your group 1 hydroxides are lithium, sodium, potassium, and rubidium hydroxide. So these are all your group 1. And then your group 2 hydroxide, so it's all of group 1. Oops, I missed cesium. Now it's all of group 1. And then your group 2 are calcium. And remember, these are +2 charge, so you have 2 hydroxides. Strontium hydroxide and barium hydroxide. So just not magnesium in group 2 and not the radioactive element. So these are your group 2. All right, so what these things do is, as strong electrolytes, I'm going to go back up to this beaker here, is they dissociate completely. So that means when you put, let's say, salt, so sodium chloride, into your water. All right, so I've got water as my solution, as my solvent. All right, so my solute is sodium chloride. Every single bit of this will dissociate. So you'll get sodium ions. And then you'll also get your, chloride ions. And none of them will stay together because they're in solution. So that's a strong electrolyte. All right, a weak electrolyte, on the other hand, these are just substances that dissociate just anything less than 100%. But they still have to be an aqueous solution. So examples are things like if I take a weak acid, like acetic acid. So HCH3COO. All right, so if I have this aqueous, it will dissociate partially. And so we draw this with arrows like this. So you kind of have an arrow forward and an arrow backwards. So it's showing that this will separate into its ions. But that it will also stay in its original form as a compound. So what you'd see in your beaker, right, so we still have that water in there, is you're going to see some ions. You're going to have some H pluses. You're going to have some acetate ions. But you're also going to have some acetic acids. Oops, I'll do that in green. So the difference is you're not going to have as many ions in a weak electrolyte as you would in a strong electrolyte, where everything becomes an ion. So you're not going to get as much electricity that is conducted through this. So I think that's it. Strong and weak electrolytes.